Hello, I'm Craig Barton and welcome to this Tips for Teachers video. Now some of you may be aware of my work with what I call SSDD Problems, and that stands for Same Surface, Different Deep. So these are problems which on the surface look quite similar, maybe they've got a key common feature, but their deep structures are different. So on the screen is the first set of SSDD problems that I ever wrote. And even before you look deeply at this, if you just glance, you'll notice that surface feature that's common. They've got this isosceles triangle. As you start to read these problems, you may also notice other surface features that are similar. For example, this question here talks about area. This question here also talks about area. But if you pause the video and study these problems, you'll notice their deep structures are very, very different. What you can also do with SSDD problems is take a more focused area, in my case of mathematics, and look at different deep structures within that area. So here I've got percentages, and again, a quick glance, you'll notice are surface features this time. Everything's to do with percentage. Either the word percentage or the percentage symbol is in everything. But we've also got this 12 and 7 and the money being surface features. But students have to sift through those surfaces to try and get to the deep structures lying beneath. And once again, if you pause the video and consider these questions, you'll realise that the deep structures, even though they're within the domain of percentages, are very different. And this led me to create my website, ssddproblems.com, where I house all of these sets of problems that have been created by teachers all around the world. So why do I think SSDD problems are a key component in the practice diet of students? Well, there are 4 reasons for this. The first is, as kind of a bit of a freebie, you get the spacing effect. So instead of giving students 4 questions based on the thing that they've literally just studied, almost kind of without being able to avoid it, you're exposing students to things that they've learnt at some point in the past. So let's imagine here I've just taught my students Pythagoras. Well, by giving them this set of SSDD problems, I'm also compelling them to retrieve knowledge about area of triangles, forming expressions, and angle facts. So you get the spacing effect, which we know is great for memory. But you get more than that as well. You get what's known in the literature as attention attenuation. That basically means students cannot operate on autopilot. You know when you get those sets of questions where once you've done one, you've done them all? That's certainly not the case with SSDD problems. Once you've done one question, you better switch back on to try and figure out that second question because a different method is going to be required. Third, you get what's known as the discriminative contrast. This is potentially the most powerful benefit, I think, of SSDD problems. And that is students are compelled to compare the questions and ask themselves, what's the same, what's different, and how does that determine how I'm going to approach the problem to try and solve it? If these problems look completely different, you wouldn't get that discriminative contrast because the questions would be so different that you wouldn't be able to really make those comparisons, or they wouldn't be as useful. Whereas if they've got this consistent surface feature, either in terms of context or in this case an image, you've got to say, okay, I can see that's the same, but what's different that means I'm going to approach this problem, let's say using forming and solving equations, whereas this problem I'm going to approach using Pythagoras' theorem, and so on. And the final benefit, and I think this is quite an interesting one, they reduce new learning interference. So what I mean by that is, and I don't know if you've ever experienced this, but you teach your students a new idea and they start applying that idea left, right and centre. So let's say, for example, I've just taught my students Pythagoras' theorem. That's fantastic, they're really good at Pythagoras, but what they then start doing is applying Pythagoras where it shouldn't be applied, for example, to solve a problem like this. Whereas by doing SSDD problems, it forces, again, students to do this discriminative contrast to make, and I think as an added benefit to that, it makes sure that anything they've learnt in the past, or anything, that they learn now, hopefully won't interfere with concepts that they were secure in the past. So that's why I use SSDD problems as a regular part of my students' practice. Is that useful to you in any way? Do you use SSDD problems in the same way as me or in different ways? If you're not a maths teacher, could you make use of SSDD problems at all? If you found this useful, I'd be so grateful if you could like the video and subscribe to the Tips for Teachers YouTube channel, and visit tipsforteachers.co.uk for more tips like this. Thanks so much for watching.